Hello! So today we're going to do Objective 5, Factoring Difference of Square Binomials. Before we get started with that, we actually have to take a look at what is a square number. Now, I know you guys know this, but just to be double sure, I just want to go through the list, and it might not be a bad idea to kind of write yourself a more inclusive list of the first 20 integers and their squares. So I said here that 1 squared is 1, 2 squared we know is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. I know you know this. But let's go through and say, well, what is x squared? Well, x squared is just the number x squared. But what happens when we square x squared? We multiply our exponents here and we get an x to the 4th. Using that same idea, if I square an x cubed, 3 times 2 is 6, so we get x to the 6th. 2x squared, we need to make sure that we're doing 2 squared and x squared. So 2x squared is really 4x squared. Same thing's going to apply if we have 2 variables. You want to distribute your squared to all variables involved, so we get 4x squared z squared. Now these are just some ideas to keep in mind when working with these binomial factoring problems. So let's jump in. We actually have a general formula for these difference of squares problems. So if we have 2 terms that are square numbers, so a squared minus b squared, the factors are just a, I'm going to actually zoom in a little bit for us here, a minus b times a plus b. And that's all it is. And watch, this works because we can do, and I'm going to do this in a different color, if we FOIL, we keep going back to this old habit here, we get a squared plus ab minus ab minus b squared. Well, look at these 2 terms in the middle, plus ab minus ab. So those are going to cancel each other out, and all we're left with is this a squared minus b squared. So if we come down here to the sum of 2 squares, where we have 2 terms that are perfect squares, this same thing is not actually going to happen. Look what happens if we had a plus b in order to get a positive sign here. We would get a squared plus ab plus ab plus b squared, or a squared plus 2ab plus b squared, which is not that. So anything in this form is actually our favorite prime. All right, so make sure that when you're working through these, you're only doing the difference of 2 squares. If you have 2 perfect square polynomials separated by nothing but a positive sign, you're going to want to say that it's prime. All right, so let's actually go through and try some of these examples. So when I do these, I like to kind of write myself 2 sets of parentheses each time, with the number inside being our a or our b. So what squared is x squared? Clearly, it's an x. What squared? And then we have a 4 squared out here, so we're just going to keep that as a 4. Okay? So here we know that our a is our x and our 4 is our b. So we are in our factored form, we'd have x minus 4 and x plus 4 and call it a day. Again, I can separate these into perfect squares. Square root of x squared is x, and the square root of 4 is 2. But x squared plus 2 squared is separated by a plus sign, so that's going to be prime. Be careful. As soon as you see that plus sign, you don't even have to do this process here. You can just declare it prime right off the bat. They all won't look super simple, so let's try a harder example maybe down here. But if we go through it, I'm going to change this problem. I'm going to make it so that it's 16x y squared minus 25x cubed, just because this maybe wasn't the best example. So what I can do is take this, and now the first thing I see, remember we always want to check for our GCF, is go ahead and pull out an x. Now I'm left with 16y squared minus 25x squared. Now this is something that's factorable using our difference of squares. I want to rewrite this as 4y squared minus 5x squared. That's because 4y squared is 16y quantity squared. 5x quantity squared is 25x squared. So now I can just fill in my formula. I'm still keeping my x. Remember, we never drop it. It follows us from place to place. My first factor is going to be 4y minus 5x, and my second factor is going to be 4y plus 5x. And of course, to check back through, we could always FOIL and then distribute our x in there, and we'd end up with 16xy squared minus 25x cubed. And that's really all there is to the difference of squares binomials. So go ahead and try the practice problems now, and when you feel ready, go ahead and try that quiz. Good luck.